So hi, good morning everyone. Last year, we were advising a company that got itself into quite a pickle. 2 years prior, they were renewing the security certifications, and external pen testers were able to gain access to the test environment and found customer data in there. Yikes. Not good. They were going to fail their security audit. At the time, their test environment was secured only by obscurity, so no wonder that external people were somehow able to get in. The solution was really simple. Lock down the environment, restrict access. Done. Now, at the time, for various legacy reasons, they didn't have a good way of managing permissions for their infrastructure. So in order to... First, they secured the test environment, and they actually did it so well that no one could get in. No one, like not even their own engineers. So in order to let them in, they had to be a little bit clever. So they came up with a very simple solution. They have created a proxy that would only let the traffic through if it came from a list of specific predefined IP addresses. Add the QA engineers to the list, done. Except sometimes developers also needed to access the environment. Can you imagine? No problem, add developer IP addresses to the list, done. Except some of those developers were working on the mobile version of their software, and for various reasons, they couldn't guarantee the same IP address. Unfortunate. So what they did was to create another proxy for the mobile app to talk to the test environment proxy, and that's how they would get in. But then the company decided to release another big piece of functionality with its own little mobile app. And guess what? In order to be able to test it properly, they had to create another proxy to talk to that other app's proxy and the test environment proxy. No problem, just another bit of configuration, another place to update if some of the IP addresses change. And it's not like any of those proxies ever failed or dropped connections. But then the company decided to release yet another big feature with its own little mobile app. And yes, they had to create another proxy. Many proxies later, the situation was, it took longer and longer to do development. Adding new apps into company product ecosystem took forever. And this one's my favorite. Onboarding new engineers sometimes even broke builds. So developers started to push code directly to production for emergency patches, bypassing all the test environment and all the proxies. It was faster that way, which meant more bugs in production. So some customers started to notice. A few of them left. And then one day, a disaster struck. One of those emergency patches contained a vulnerability that resulted in potential exposure of customer data. But don't worry, the data in the test environment was perfectly safe. So how did that happen? How did a team of smart, talented engineers end up in this ridiculous mess? How did they end up, from that very small, very rational decision to lock down the test environment, how did they end up losing customers and endangering the data? I'm Dorota. I work at Authorize, which is a login and access control API. So if you're writing software, you need your users to log in or have granular permissions. Instead of coding those bits yourself, you can use Authorize. And in our space, identity and access, it is something that we see a lot. A small, innocent change having big impact many months later, and it's not always the way it was intended. But it's not just in our space. It's something I've experienced again and again throughout my 20-year career in software. I feel old saying this. But it always goes like this. We have a problem. We make an obvious change, which causes another problem, and that problem causes another problem and another one, and before we know it, we're looking at a dumpster fire. And yes, we could look at the fire and say, this is fine. Or we could try not having that problem. The thing is, us engineers tend to think in algorithms. We focus on tasks and desired states. One thing leads to another, and yes, some steps may be async, we may have some if-else or loops along the way, but in the end, we expect a singular deterministic result. And it's a very good way of thinking. It makes us productive. But it is also our greatest weakness. And that's what led that team I told you about towards the proxy madness and endangering the data. If we only ever look at a single problem at a time in isolation and focus on tasks and states, we fail to grasp all the consequences of our changes. That's because the consequences of our changes have their consequences. And those consequences have their own consequences. And those consequences have consequences, and so on. And not all of those consequences will align with what we're trying to achieve. So let's have another look at the situation I told you about. What happened was, external pen testers were able to gain access to an unsecured test environment and found some goodies there. If this is your mental model of the situation, then the solution is really obvious. Lock down the environment, secure it. Done. What can go wrong? But the reality was a little bit more complicated than this simple picture. If we take a step back, zoom out just a little, we can see that we also have QA engineers who use the environment to do their sorcery. We also have developers who continuously add bugs to the environment for everyone's enjoyment. And the testers and developers talk about those bugs, which causes more or fewer bugs over time. And this data right here, it didn't end up there through some mysterious tier in space-time continuum. There's a process that put it there. So we only took one step back, and we can already see that locking down the test environment is likely going to have more consequences than just securing the data. But that's not all. If we take another step back, zoom out just a little more, we will see that the developers aren't there just to put code into test environment. They put that same code in production. And that's where customers go to find their delight. That's where the data comes from. And we also have PMs who set grueling deadlines for developers while making sweet promises to customers. And the QA engineers have a very special process to make the PMs cry. Actually, everyone cries when there are several critical issues right before the big release. Well, the point is, once we update our mental model to include all of those people, processes, and their interactions, we can see that making this change right here to the test environment is likely going to cause ripples throughout the whole system. It's going to come with unintended consequences. So, all we had to do to anticipate a disaster in the making was to take that step back and ask, okay, we're going to do this. We're going to secure the environment. And then what? With that expanded point of view, we could have seen that our simple solution maybe wasn't so simple after all, and that there were other solutions possible with their own, maybe more acceptable outcomes. And this, taking a step back, zooming out to look at the surrounding adjacent parts to the problem we're trying to solve and asking, and then what? It really doesn't take long. And if you make it a habit, it happens almost automatically. So we should really all be doing this before making any changes, no excuses. Just take a moment, 1 minute, doesn't take longer. Look beyond tasks and states. Look at all those people, processes, their interactions, and ask yourself, okay, if I do this, and then what? What other bigger parts of the system are going to be affected and how? If you do that, I guarantee your future selves will be much happier. But wait, there is more. Many years ago, I worked at a company with a large monolithic code base, and it wasn't just a monolith, it was a behemoth. I'm talking about thousands of C# projects with who knows how many files, or intertwined spaghetti style. It would have been glorious if it weren't so tragic. Luckily, our unit test coverage was fantastic. Just kidding. No, it wasn't. Other than a handful of projects scattered throughout with 1 or 2 tests each, there was nothing. Unit test desert. Those were the times where you could just push your code directly into the release train without any testing, and someone else would take care of it. Good old times. Anyway, at some point, our senior software leaders realized that maybe this wasn't the best. So we had this massive push for unit testing. And I remember we had this big all-hands meeting where the leaders were saying how unit tests are great, we should all start adding them. And in fact, missing unit tests is a form of tech debt. So we should all start adding unit tests in our tech debt time. We had this tradition that whenever not on an important project, every engineer would spend at least one afternoon every week cleaning up tech debt of choice. So after that all-hands meeting, everyone was so excited about unit tests, so motivated. For sure we were going to see a lot new unit tests, right? No, it didn't happen. And some of you may already be forming some theories as to what happened, but I want you to hold that thought. Our reality was actually more tragic. So one of our engineers, a very smart, motivated guy, was so excited about unit testing that he decided to help everyone. And he had some time on his hands. So he went over our code base, and for every C# project that didn't already have a corresponding unit test project, he went ahead and created it. He didn't add any tests. He just created an empty unit test project for every one of our C# projects. It had the right folder structure, right dependencies, but it was empty. Seems like it would be helpful, right? It prepared everyone for adding unit tests. So why were there no new unit tests added after that? Well, our engineer probably thought about this problem like this. Step 1, create a unit test project. Step 2, add some tests. Step 3, okay, maybe this isn't how he thought about this. It was probably something more like this. For every C# project, step 1, create the unit test project. Step 2, add some tests. Now, if this is your mental model of the situation, then doing that first step for each project, it may make you believe that you're doing a lot of work, you're helping everyone. Maybe you're even doing half the job, right? Half the steps, half the job. But the reality was a bit more complicated than this. So in reality, all our engineers were normally super busy doing very important things like arguing implementation details for this new feature, attending various Scrum meetings, playing table football, adding bugs, features into our code base. Meanwhile, our behemoth lived its own life, secretly evolving, developing tech debt in the darkest untouched corners of our code base. And when a clock strikes midnight, all our engineers would drop whatever they were doing, and they would go hunting for that tech debt that mysteriously sprung up when no one was looking. Now, missing unit tests was just one type of tech debt we had, believe it or not. So every time there would be a choice. Which kind of tech debt should I squash next? So our engineers would have a look at the code base, poke around, find a particularly disgusting looking piece, and then work on that. Now, before, there were many places within our behemoth that screamed, "I have no unit tests, I'm empty, please add unit tests here." But now that every one of our C# projects had a corresponding unit test project, It was impossible to tell at a glance which area of our code base needs some unit test love. And in fact, looking at a single project in isolation, it appeared as if someone just recently spent some time adding unit test shaped things to it. So that engineer, bless his heart, who created all those projects, and he really meant well, all he did was to remove an important signal. And that's what killed our initial momentum. The consequences of our changes have their consequences. As we take our step back to look at people, processes, and their interactions, there's one thing we should be paying special attention to: signals, feedback loops. Feedback loops are all those places where an output of an action or a process causes some change that impacts that same action again in the future. Now, creating, modifying, or removing feedback loops tends to have a delayed, dramatic effect on how the whole system works. Some feedback loops are very simple. They are like thermostats. A signal causes something to happen, which removes the signal until it gets triggered again. It's like when we have a critical production issue, we get paged, we fix the problem, that removes the alert. Or like when a missing unit test project tells us to add unit tests. Some feedback loops are self-reinforcing. So a signal triggers a behavior, which produces more of that signal, which causes even more of that behavior. So it's like when we are slow to deliver features, we start cutting corners, introduce tech debt, which makes us even slower. So we start cutting more corners, more tech debt, and so on. Or the other way around. We start measuring velocity, we invest in removing tech debt, it makes us faster, makes it easier to remove even more tech debt, makes us even faster, and so on. So these are the virtuous or vicious cycles. And once started, they can be really difficult to stop without some fundamental changes to how the system works. Some feedback loops play over multiple steps and long periods of time, so they can be a bit hard to spot. It's like when we're under pressure to deliver, we let some bugs in production, some customers notice, they get frustrated, they may leave, the company gets less money, they may cut the engineering budget, so remaining engineers are under even more pressure to deliver, even more bugs end up in production, more customers leave, and so on. Classic death spiral. Recognizing these types of loops takes a lot of practice and a lot of asking, and then what? And recognizing feedback loops is what helps us to avoid or to cause the most spectacular effects. So when we create a new monitoring dashboard, we may or may not be adding a new feedback loop. When we fix an old bug, we may or may not be modifying an existing loop. When we're automating a manual step, we may or may not be adding a feedback loop. Wow, so helpful. Now, I'm not saying this so that we get stuck and don't want to make any more changes out of fear of unintended consequences. I'm saying this so that we can be more intentional about what we're doing. And that requires us to recognize when our actions intersect with some of those feedback loops. So here are some tips on how to recognize whether that's the case. Just ask yourself, okay, if I go ahead with this change, will it cause something new to emerge? Will someone start doing things that they haven't been doing before as a result? Or maybe they'll stop doing things or just do things differently. And then take that step back, take a look at people, processes, their interactions, and ask, and then what? What other parts of that bigger system are going to be affected and how? Like that, you may be able to recognize those feedback loops and use them to your advantage, because you are able to drive a lot of desired behaviors by creating or removing some of those feedback loops. This is very powerful. So let's have another look at our unit test problem. and the engineer that killed our momentum. The way this initiative was framed, missing unit tests, a form of tech debt, meant that we had a very simple loop in place. If tests are missing, add some. Now, this may be good as a good starting point, but it meant that this feedback loop was very weak and brittle. And in my opinion, and some of you may have recognized this instantly, our leadership made a mistake here. Lumping the missing unit tests with other forms of tech debt may be semantically correct, but the process to address those is very different. So if we wanted to see any sustained progress, we needed a stronger loop here. Now notice that adding unit tests makes it easier to add more unit tests. Because it's easy to add cases to an existing scenario, we have more examples to copy-paste. So this could be at the beginning of a self-reinforcing loop, if only we find some trigger to trigger this consistently. If only there was some sort of event that would force us to scrutinize the code so we can flag which area needs some unit tests. Oh, wow, we had that. Code reviews. So once we've coupled the code reviews to the check for the missing unit tests to code reviews, things started to snowball. That is because this feedback loop is not only consistently triggered, it's also self-reinforcing. So the consequences of our changes have the consequences. When we take that step back to look at people, processes, and their interactions, we may be able to spot those feedback loops. And by asking, and then what, we may be able to use this to our advantage to drive the behaviors in the way we want. And we could just as well stop here, but wait, there's more. A colleague who works at a company that does content streaming, among other things, I really cannot name any names, told me about this internal tool they have. The tool allows non-technical people to manage content on their platform. So things like setting release dates, languages, fonts, graphical assets, all this exciting stuff. I'm going to call this tool COMA, for content management, but also because looking at its ugly UI for too long would put you in a coma. Like many internal tools, this one was really poorly named, but it was also really ugly. But it had a personality. It was quirky, to put it politely. But for the most part, it did its job. And the important part of that job was to make sure that no matter what the content managers do, they would not break the database in production. And the engineers who wrote that tool, they were smart and they were nice people. So over time, they wanted to make the lives of content managers easier. So they started to introduce all sorts of improvements. The tool started to look nice, it was pleasant to use, and they also introduced a bunch of validations that prevented some of the mistakes that would look bad in production. One of those validations meant that you could not set the release date to be in the past. So you could only publish today or schedule it for the future. It made sense if you think about it. You cannot change the past, even if you lie about the dates, unless you're in that time travel stuff. And it was important to have the correct dates in the database because that's what a lot of other teams, including finance, relied on for their reporting. So everything was great. Everyone was happy. Until one day, a disaster struck. One of the new, highly anticipated pieces of content that was meant to be released much, much later that year suddenly appeared on the platform for everyone to see. And then everyone saw it. So this whole promotion machinery, hyping up the release, slowly teasing the fans, preparing them for what's to come, the interviews with the artists mentioning the release date later that year, advertising referring to that release date later, all of that became undone. Confusion, embarrassment. Lawyers got involved. And we know that when lawyers get involved, the fun is over. So they had this big investigation at the company and this huge all hands on deck post-mortem meeting with all the questions like, what happened? How did it happen? How do we make sure it doesn't happen again? Where is my coffee? All eyes turned to content managers and the internal tool that was supposed to protect everyone from this very thing. So it turned out that the content managers were smart people. They didn't publish things willy-nilly. They tested their stuff before release. Testing, the root of all evil. So they had this special, very secret test location where they would publish the content to, have a look, make sure it was fine, and then release it for everyone else. And normally they would use their internal tool, Coma, to do all of that because it was convenient and it protected the database from any travesty. But this new piece of content was a little bit special. Some of the graphical assets were meant to change over time so that the content would look one way at the release and then differently a few months later. And they had some really clever code to handle all of that. And we all know that clever code is like Schrödinger's cat. It can be indeed very, very clever, or horribly stupid, and we won't know until we test it. So that's what the content managers did. They wanted to see how the content would look like 3 months after the release, and I think you see where this is going. They couldn't use their internal tool to do that because it wouldn't let them set the release date in the past. But smart people don't give up so easily. They were friends with database people, as any reasonable person should be. So they asked one of the DB admins to run this query, set the release date 3 months in the past for this new content for the special test location. And you've probably guessed it, the person running the query forgot to add that last where location statement. Drama. So how do we think? What should the remediation here be? What would you do to make sure this does not happen again? I bet some of you are thinking, let's protect the database. Let's put some process in place, some validation, some check, maybe some reviews. And you wouldn't be alone in thinking that. But that's thinking in algorithms again. Let's have another look at what really happened here. So the engineers who wrote that internal tool seemingly did all the right things. They realized quite soon that their ugly child was not just there to provide the board content managers with entertainment. They knew that it was in fact a source of great power, because whatever happened here would get chiseled onto stone tablets and locked up in a vault, saved in their central database. And a lot of people would look at this data with great awe and do magnificent things with it. The cryptic finance people would translate this data into alien tongues of invoicing and reconciliation reports. The elusive analysts would use this data to spin their quarterly projections into believable tales. And perhaps the most important of all, the dashboard. Maybe not planet scale, but the dashboard, the important one that all of the important managers would look at every morning. That dashboard was also built upon that data. So the engineers realized all of that. They did the right thing. They took that step back, looked at the people, processes, their interactions, and they realized that any mistake here would cause a lot of unintended consequences. And so they did what any reasonable person would do. They solved the root cause of this hypothetical problem. Or so they thought. What they didn't account for was that one day the requirements would change. Oh no, how does this happen? And once requirements changed, the system adapted. Notice that some parts of the system are static in nature. They remain the same until someone goes and does something. Other parts of the system are adaptive. It's all those pesky humans going around having ideas. So that's what the engineers who wrote that tool didn't really consider. By implementing rigid validations within the tool, they created a choke point, an obstacle that some of the adaptive parts of the system had to go around. And go around they did. And it wasn't a nice, safe path for them to follow. So the consequences of our changes have consequences. And it may be really hard to reason about all of those future unknown consequences from where we're at. And as soon as we add adaptive parts of a system, so humans who have brains and ability to be creative, anticipating all of those unknown consequences is impossible. We can't account for every edge case, every possible mistake, which means mistakes, unexpected things will happen, and our system will adapt in unknown ways. A very natural reaction to that is to add some restrictions, some process. Let's eliminate all the possibilities of human error. But all that does is to make our system more rigid. It creates those choke points. Meanwhile, the adaptive parts of our system continue to be adaptive. When faced with a blocker, they will simply repurpose another, less rigid part of the system, often in unexpected ways. And this repurposing often happens silently until something breaks. And once something breaks, we're tempted to add even more process, more restrictions. See how this is a vicious cycle? But now that we're aware of this mechanism, we can actually make our system more resilient for those unexpected adaptations. And contrary to what our intuition may tell us, the way to do that is not by adding more process, more restrictions, not by hardening anything. It is by creating a pit of success. A pit of success is when it is so easy to do the right thing that it happens almost by accident, that we fall into that pit of success. So it is about enabling the good outcomes more than it is about preventing the bad ones. It's more effective to do that, to focus on the good outcomes instead of preventing the bad ones, because humans tend to pick the path of least resistance when following their goals. So let's have a look at our content management oopsie again and see how we could apply it. So what happened was the internal tool for managing content was too rigid. It created a blocker that the adaptive parts of the system had to go around. In doing so, they broke the database in production. Now, our instinct may be to fix this, maybe to put protections around the database, process, restrictions. But now that we know better, we know that the way to fix it is actually doing the opposite, is to remove restrictions. This is very counterintuitive. Remove restrictions and instead create a pit of success here within it all. How that looks like exactly, well, I'm not a consultant, but I can say it depends. In this particular case, it may be, instead of blocking operations, just nag the users. Are you sure? It's dangerous. Are you sure? Or do something fancy, like set the location to the test location by default. And I bet any UX person would come up with more ideas. The important part here is to help the content managers succeed, instead of trying to prevent their failures. Like that, we're building in flexibility into our system so that it can absorb some of those unexpected adaptations, unexpected things. Okay, I talked a lot. We're falling asleep. Let's just do a small recap what we talked about. So the consequences of our changes will have their own consequences. We may be able to anticipate some of those consequences by taking a step back, looking beyond tasks and states, looking at people, processes, and their interactions. And by asking, and then what, we may be able to prevent some disasters, or we may be able to spot some feedback loops within the system, which then we can use to our advantage to drive the behaviors in the way we want. Most systems have adaptive parts within them. That's usually humans, which means unexpected, unknown things will absolutely happen. And we can make our systems more resilient towards those unexpected adaptations by creating a pit of success. And if all that fails, this is fine. Thank you so much.